Good day. I'm Vincent Saxtetter, and this is the After the Age of Fire channel. This is episode 20, recorded on December 6th, 2025. The title is Why All Renewables and Nuclear Strike Out. Why they always strike out. Or there's an alternative title, Why the Biosphere is Always Better. Biosphere meaning food, fodder, wood, coal, oil, and gas, all the things that came from plants, and renewables and nuclear means everything else, everything that didn't involve plants. Um, just to recap what this channel is about, this is kind of a prepping channel, but not your average prepping channel. Right now we're coming to the end of around 250 years of doubling our consumption as a human race every 22 years or so. So every generation had around twice as much as the previous generation. That's averaging across the entire world's population. Of course, it wasn't distributed equally. Some people were doubling before other people were, and some people never doubled. Um, but at any rate, we're coming to the end of that now, and we're at a point where sometime around now, give or take 20 years, we're coming to the end of this doubling, and then sometime after that, maybe 50 or 100 years from now, we'll arrive at probably having less energy available per person than we do now. Right now, it's 46,000 calories per person per day plus food, fodder, and wood. The food, fodder, and wood is another 15,000. Um, and it's unclear. Almost all of that, 40,000 of that comes from coal, oil, and gas. That's plants, old plants. 15,000 comes from food, fodder, and wood. And another 4,800 comes from renewables and nuclear. And we've been over in the last episodes our prospects for continuing our consumption of 40,000 calories per person per day from coal, oil, and gas, or even doubling or redoubling it as we have been for the last 250 years. And it looks like we might be able to double or even redouble our consumption in the next 50 years. But pretty soon it's going to be harder to obtain them, and sooner or later we'll have less on hand. It'll be a lot more work to get them. We'll have less on hand than we do now. So 100 years from now, we'll probably have 100 or 50 or maybe 200, but sometime fairly soon, as human history goes, we'll have less than 40,000 per person per day. And we've also looked at renewables in a lot of detail over the last 4 episodes. And right now they provide 4,800 calories per person per day. And judging by the price, just the price, and not necessarily all the other difficulties that come with building these things, it looks like we'll never get more than 15,000 calories per person per day from renewables and from nuclear. So today it's 2,000 from nuclear, 1,360 from hydro, 750 calories per person per day from wind, 530 from solar, and 100 from geothermal. So it's a minuscule fraction of our total energy consumption. Our total energy consumption is something like uh, 15, no, around 30 times what you eat in a day. The average person consumes 30 times that, and our energy from non-plant sources, from the renewables and nuclear, is only 2 times what we eat in a day, averaging again across the whole world. Um, and so this episode is about why we always why the renewables always strike out. Um, and I don't think I finished explaining what sort of channel this is. The whole point of this channel is to say where we've been, where we are now, in a point of transition, and how to prepare yourself and your family to thrive and flourish as we go through this transition and enter a different a different a different world than we are in now, one where we can no longer count on having twice as much of everything. And I do think it is possible to flourish and to do very, very well in the new world. Certainly before 250 years ago, nobody could count on doubling their energy consumption every 22 years, and still there was a lot of good lives lived long before. It wasn't just the rich people. So I think it's possible again, and it'll be on different terms than they were 500 or 1,000 years ago. So this channel is about preparing yourself and your family, and what will give the most likelihood that your family line will continue and that your family will thrive. So, but this episode is I've gone over the renewables and nuclear, and found that on the basis of price, we'll never get more than 15,000 calories from them, any combination of them, per person per day. And so they won't be able to make up the difference when our supply of coal, oil, and gas goes away or reduces. We'll never completely run out of coal, oil, and gas, but we'll have less of them and they'll be harder to get. But so when we have less of them available, can we make up the difference with renewables? And the answer is no, there's just not enough. We won't be willing to spend, we won't have the money to spend to build enough renewables to make up the difference. And so what's left is food, fodder, and wood, and we'll come to that in the next episodes. But before that, I want to, instead of talking about the price of renewables, I want to talk about a deeper reason and a much stronger reason why renewables always strike out. Everything you can think of that doesn't involve plants, that doesn't involve the biosphere, always strikes out. And there's a very good reason for it, and it's far deeper than price. Price is just a reflection of that. So, price, of course, involves all sorts of ins and outs and uncertainties and different people's judgments and investments and returns on investments and risks and so on, and inflation. And it's endlessly complex, and so you can always argue about price. I want a better reason for thinking. I think I did my homework and I told you about it. I told you all the details, well, many of the details, and then I can supply more, or you can just look them up on the internet. Certainly they'll be in the book. But I think there's very good reason to think that the renewables will remain as expensive. So expensive that we won't build that much. But I'd like to have a reason that's more rock solid. And so in this episode, I'll talk about that and give you another reason that's a lot deeper. And then coming up, I don't know, probably a couple months from now, there will be yet another reason, which is even deeper and even stronger. But this one, and then there will be 3 lines of argument. Today I'm giving you the second. And the bottom line is, and I'll spend the rest of this episode unpacking it, the bottom line is that the biosphere, and I mean all the plants and animals and everything that works together, or if you see competition, sure, there's competition, but all of the animals and plants on the surface of this earth, underneath the surface, and the air, and so on, all of the living things here somehow provide for our needs, our specific needs as humans and as a race, and in a way that's nearly optimal. That means it's doing nearly the best job it could of taking care of our needs. In other words, given the physical situation that we're in on a planet that's circling this particular sun, with this particular set of elements on the surface of the planet, and the water the way it is, the sea, and the weather, um, the plants and animals, given that particular circumstance, are doing just about as well as any possible solution could for providing for our specific needs. Um, and the reason why they're doing nearly the best possible job of providing for our specific needs is that we grew up here on this planet with these particular plants and animals, coping and learning to profit from them as we evolved. I should say just a note about evolution. I've already mentioned evolution several times in previous episodes. This may put you off some people would be put off that I'm talking about evolution, and I won't be shy about saying that the age of this human species, or the age of living things have been on this planet around 2 billion years. I won't be shy about that at all. But I think that if you don't happen to subscribe to evolution, if you're one of the people who thinks that the world originated some 6,000 years ago by fiat, I don't think that necessarily means that my arguments are blown away. And hopefully I'll do an episode about this, or make some comment someday about evolution. I just don't think it's the top priority. It's not highest on my priorities. But I think even if you don't believe in evolution, if you're a creationist, I think you still need to understand the world in front of you and the biosphere and the way it's organized in some way, and all the complexities of the way you have to think about what its structure is, and I think evolution is one way of understanding, of trying to find some rational way of understanding the structure, like looking at a building, seeing what the foundation is, what the levels are, where the roof is, and what the function of each part is. And whatever way you come up with for understanding the structure of this particular planet and of the living beings on this planet and the history of this planet, you'll still come up with conclusion. I think you'll still have to build a very, very deep and intricate understanding of this planet and of the living beings here, and you'll still come up with us fitting in a very specific way with a whole community of living beings. And that's the fundamental reason why this particular community of living beings, animals and plants, does better for us than just about anything else could. Because we grew up here, and our whole bodies are built, and everything about the way we live is built to fit into this particular biosphere. And so it does a better job. Now I'll unpack this in the rest of this episode, but first I want to give a qualification. I say the biosphere is nearly optimal. Nearly optimal means maybe it could be improved a bit. Okay, I think in the next few chapters, the next 7 or 10 episodes will be about different things one might do to try to improve the biosphere, and first of all how it works, and then how to improve it. But in the end, after going through all the details, it looks like even a factor of 2 increase in our harvest from the biosphere would be a stretch. In any case, any improvements, so being nearly optimal, the biosphere being nearly optimal for our needs, means that any improvements that we could make to the biosphere will be hard to find, that there aren't too many of them, and that they will require an awful lot of work and risk worldwide. we'd have to work awfully hard in order to get a factor of 2 improvement from the biosphere. So maybe there's a little bit of give, maybe it could be tuned a little bit, but it's already very close to providing for what we actually need. So that's the overall message of this episode. Now let's get into the details. Well, first of all, you might think that the biosphere is not really optimal for us. It's not the best. After all, out of each calorie of sunlight that hits the Earth's surface, only 1 out of 345 of those calories is harvested by the world's plants. The rest turns into heat, gets radiated away, or is used to evaporate water, drive the weather system, and so that's a huge inefficiency factor. And then out of those 345, that 1 out of 345 calories is harvested by the plants, and then of those calories that are harvested by the world's plants, we get only 1 out of 11. So in total, we get less than 1 out of 4,000 calories that come to the Earth in sunlight. That may seem just disastrous, and it should be a no-brainer to get a better harvest than the biosphere does. I mean, who could have come up with such a stupid system, and how could we not do better? Okay, well, the key here is, what do we really need? Okay, we don't just need calories. Okay, for instance, if we just needed heat, then Venus would be a great system for a great planet for us. Okay, Venus captures more sunlight, has more greenhouse gases than our planet does. It captures sunlight better. It keeps the surface of its planet. The planet is warmer, and so why don't we just, well, we can't live on Venus. It's impossible to live there. I think it's acidic. It's terribly acidic. Nothing lives there. Okay, it's not just heat that we need. So let's talk about some of the things that the biosphere does well, that suit us, that give it a reason for harvesting so little. It does things very well for us that we can't begin to compare to. Okay, for one thing, the world's plants, they grow from the resources where they are. The seed falls in a particular place, or the lichen, or whatever it is, it falls in that particular place and starts growing, if it can, with whatever that there is around it. And they grow almost everywhere on the surface of the Earth, all on site. Okay, and that's a huge thing, to be able to grow where you're planted. Okay, we instead, if we want to get anything done, we first go to some place where there's something we want, we extract it. Okay, we take it out, we dig it out, or we cut it, or whatever, and then after extracting it, we purify it. We separate the things that we don't want, and we discard them immediately, or later. Sometimes we do the purification and discarding in stages, and then we transport that thing to a place where we'll use it. Okay, after we've transported it, for instance, everything in my home came from somewhere else. Even the home itself came from somewhere else. Parts of it came from very far away. All of it came from distances long enough that it would be very hard to carry them myself. All the concrete and so on, I would never want to do that. And then if I look at where they came from, say, let's talk about food, for instance. You go to your cabbage patch, and you choose a cabbage, and you pull it out, and then immediately you're throwing away leaves, and then you're moving it somewhere, and then you're processing it some more, and then eventually you eat what you like and throw away what you don't. Well, that's relatively good factor of that's a situation where maybe the cabbage patch is close to you, and maybe you're throwing away only a third of the cabbage. But for most of the things that we use, we're throwing away 90% of the material that we dig out of the ground, and we're having to move the material kilometers or thousands of kilometers, and it's a huge expense. Huge amounts of energy go into moving things around, refining them, discarding things, and the biosphere just doesn't do that. It's a huge advantage. The second advantage that the biosphere has is that it determines almost everything on the Earth's surface. It has a power and control over the Earth's surface that we cannot begin to equal or imagine. You may have heard of terraforming, which is a science fiction idea where you go to some planet which is not good for humans. It doesn't have the soil that they need, and maybe it doesn't even have atmosphere. So in this science fiction story, humans arrive and they begin to do work on the land, creating soil and creating an atmosphere until they are able to thrive on the new farmland under the new atmosphere. The only real terraforming that has ever happened, and that will probably ever happen, is the terraforming that happened on this planet over the last 2 billion years. 2 billion years ago, there was no oxygen in the atmosphere, and the living things, living microbes on this earth, all found oxygen to be poisonous. It does react very easily, as we see in fire and in our lungs, and they couldn't stand it. But somewhere around 2 billion years ago, a new type of microbe, something related to today's algae, started producing oxygen as waste and gradually filled the Earth's atmosphere with oxygen. The world's atmosphere as we have it today is a product of living beings. Those same living beings are the ones that exist today are also responsible for all the soil on the earth. If there weren't living beings, we'd just have clay and sands. We wouldn't have soil. Much of the bedrock underneath us by now is made out of dead living beings. They also tear down mountains, and they make rivers and valleys. Probably the rivers and valleys, the river systems that we have today are the result of the way that living beings happen to live on the surface of that land. And 2/3 of the rainfall on the Earth's land is caused by the plants growing on the land today. What happens is that rain from the sea falls fairly close, within a few hundred kilometers or 500 kilometers of the coast, and that when the rain falls, the plants, their roots and the soil that they've created are able to absorb the water instead of having it run off immediately in flash floods. It absorbs into the soil and moves along slowly, and then the plants take that water and they use it during photosynthesis. We'll get into this. They use huge quantities of water during photosynthesis. We'll get into this in the next episodes. They take that water and they evaporate it into the. In fact, if they don't have water on hand to evaporate, they can't harvest energy. We'll get into why very shortly. But anyway, it evaporates because of the plants, and then it turns into clouds again, it moves inland, some of it moves inland and rains again, and then again. And so you get this conveyor belt moving moisture inland from the sea, and that conveyor belt is fueled entirely by plants. About 2/3 of the rainfall on the Earth's land happens because of plants. And if you go far inland, say 1,000 kilometers, all of that would be desert if it weren't for plants. And we just can't compare. We just can't begin to do the things that the biosphere has done to this Earth. We don't have that power, and I don't see any way that we ever will. Any power that anything that we can do to terraform this planet requires huge amounts of energy. Where are we going to get that energy? We'll get it from plants. So anyway, just the world's plants, the biosphere, has a control over this planet that we cannot begin to equal. Another thing that the biosphere does, and we'll get into this again in the next episodes, is it grows itself. And I think it's easy to look at a plant and miss what you're seeing. Any plant, actually even any cell, is far more complex, intricate, and hard to understand than the most complicated devices that the human race has ever made. We look like fumbling idiots compared to a cell or to a plant that's photosynthesizing. And you look at how they do their work, it's just, I don't know, we could barely begin to understand what's in front of our eyes, even with modern technology and textbooks that go on for 500 pages going over the intricacies of the chemistry inside of a cell. Oh man, it's just amazingly beyond us. And the plants do it without us. All we need to do is plant a seed and give the plant somewhere to grow and try to help it along, and it grows itself. It's building technology that makes our high tech look like nothing, and it's building it in huge quantities. It covers the face of the Earth with green every year. Not only is it high tech beyond our imagining, but it's on a scale that we can't begin to equal. We can't cover the face of the Earth with anything. So if we want to harvest sunlight better than the biosphere, more of it than the biosphere, you can count on it requiring more effort and more resources and sacrifice from us than we would have to give to the biosphere to do the same thing. Because instead of the biosphere building its high-tech machinery, its chlorophyll molecules, which are tiny little antennae, and all the rest, endless intricacies, we'd have to do it all ourselves. Maybe a little easier to grasp and a little more believable for most people who are used to looking at a leaf and thinking it's just a leaf instead of something more high-tech than a supercomputer. Something easier to grasp is that the biosphere stores energy extremely well, far better than anything we can do with our own technology. So let's talk about the amount of energy that is stored in a kilo of grain or sugar. Now these are created by the biosphere, okay? That's the same as the amount in 460 grams of fat or oil, vegetable oil, that costs around $1 maybe, or 370 grams of gasoline, also around $1. And take these small quantities of cheap materials from the biosphere. And our best energy storage technology is a lithium-ion battery. The same amount of energy requires 30 kilograms of lithium-ion battery, which right now costs around $700. So the price point for for the biosphere's energy storage technology is 1/700th of our price point, and its weight, well, if you want to compare gasoline to lithium-ion battery, it's a factor of 80 better. Okay, we can't begin to match how well the biosphere stores energy. An electric car today will have a half-ton battery, and that battery will hold around 86,000 calories. It'll cost $10,000 to $15,000 for that battery, and it will hold the same amount of energy as 10 liters or 2 gallons of gasoline, which would cost $9. Now, I mean, a small fraction of a full tank of gasoline. Now, the car does use the energy stored in its battery 3 times more efficiently than a car does when it's burning gasoline, because when you're burning gasoline, you're throwing away a lot of waste heat. But still, even with the factor of 3 multiplier, that means it can only go as far as a car that has 6 gallons of gasoline. Everyone knows that a compact car can hold a lot more than 6 gallons of gasoline. Even a normal sized tank will hold 12 or 15 gallons. So an electric car won't go as far as a normal car will, even though it has a high-tech battery that weighs half a ton and costs $10,000 or $15,000. And the energy storage that the biosphere gives us is stable, it's resilient, it's adaptable, and it's practically foolproof. You can cause. We all know that you can make food rot, or you can pour gasoline on the ground and it won't be useful anymore. But it's nothing compared to what you need to do. Say with the lithium-ion battery, for instance, you make a small dent in a battery, and that can be enough to start a fire. And once the fire starts, it's impossible to put out practically. So that's why the batteries in electric cars are covered in thick sheets of steel, because even a microscopic difference compared to that, you take the biosphere's energy storage, say some oil and some vegetable oil and some grain or something, and you can cook it and you can mix it around, you can do whatever you want to it, and it'll still be good to eat, or at least it'll still have all the calories there. Well, it's amazingly versatile. You can take a piece of wood and you can do anything you like to it. You can make furniture out of it. You can turn it into toilet paper. It still has all of its calories. Do that to a lithium-ion battery and good luck to you. Or to anything else that we store energy with. Say dams. You have to be immensely careful with your dam, or else it'll spill and flood and kill people. Anything else, any other way we have, requires a lot of care and really wants to fall apart sooner or later. Another point is, I don't think we can go on, I don't think you could possibly give too much time to these points. They are just of world-shaking importance. Um, Energy can be kept, the biosphere's energy can be kept in reserve for years, even millennia. That's what coal is, millions of years old biosphere energy. Um, but certainly, if you keep your grain away from pests, it'll last for years or tens of years. Your wood too. Um, just keep it out of the rain. Um, it's a great way of storing energy. The biosphere you can just, that's why we can get through the winter. It's because the biosphere makes it really easy to line up to fill your cellar with food, and your outhouse or your shed with some wood, and get through the winter. It also makes it It also gives us the body fat that we have that allows us to get through the night. If we relied on electricity instead of fat, then when the lights went out, we just die. But that's not the way the biosphere rolls. And the fact that energy is so light is the reason why there are animals and seeds why they exist at all, actually. An animal is able to move and make a profit from moving because it stores energy very lightly. If I have a few kilos of fat in my body, it could be even 10 kilos, I don't know. That would be tons of batteries, and if I had to carry around those tons of batteries, I just wouldn't move. And if every living being had to do that in order, seeds would weigh, a little seed, an apple seed, would weigh 100 times more. It wouldn't get very far from the tree. It's all multi-purpose. It's unlike the things that we build. The devices we build are not generally multi-purpose. They have exactly one purpose, and hopefully it does it well. A microphone or a hammer. The biosphere's products can be used for endless varieties of things. And one more thing is it doesn't produce waste. Everything that the biosphere produces gets reused for something else. We produce everything we do, everything we create turns into waste, and then we're done. And there's these are all advantages of the biosphere, and these are all reasons why it provides for what we need and what we want far better than any other option. And it plugs directly into us. Every detail of our body is organized for feeding off of plants and animals. From every organ, even the structure, the shape, everything is there to get food in your mouth and waste out later, and for your body to roam, for you to roam around the world finding food and growing it. In contrast, our bodies don't have an electrical hookup. There's no way to feed us with electricity. There's no port for steam that will make us go. There's no power shafts that you just plug us into a motor. No, we're designed for one particular way of getting energy, and that's the energy that the biosphere supplies. And the reason for this is of course, we are part of the biosphere and we are not separate from it. We are built both to receive from it and to give back to it. That's how we're architected. That's what we're for. Before I referred to evolution, us growing up in the biosphere, but you can forget the evolution point entirely. You can just say, this is the way we're built. We have not obtained ascendancy over the biosphere. We don't have a role that's separate from the biosphere. We don't stand above it. I'm a Christian. I've mentioned that there is a way that there's something special about it. So I'm not trying to put us down on the level of animals and plants, but we're part of it. We can't. It's not like us and them, us and it. There's no way to make a distinction between us and it. We're part of it. Now this is a direct quote from the text. Any proposal to produce most of our energy from sources other than photosynthesis, from non-plant sources, is ultimately a proposal to re-engineer our own selves, including not only our bodies, but all aspects of our existence. It may look like it's a simple thing to get most of your energy from windmills, wind turbines, or from nuclear energy. But in the end, it means if you're trying to get most of your energy from that source, it means restructuring your whole way of living and ultimately your body, your way of relating to everyone else, everything about you in an unimaginably different way. So we can't expect anything comparable in function or satisfactoriness comparable to the biosphere anytime soon, because we're built for it. We're built for the biosphere. And the biosphere, 2 billion years in the making, and our own role in that, maybe the first walking two-legged animal related to us is 3 million years ago. All this going over unimaginable timescales. You can't begin to. There's no chance, absolutely zero chance, that in decades or a few hundred years we could begin to equal the satisfactoriness of the present arrangement, the present way of getting energy, which is from the world's plants and animals. We just don't have the resources, the brains, or the time. It provides for us as nothing else can. And again, coming back to other ways of trying to get energy, are re-engineering ourselves. They're not just re-engineering ourselves, they're trying to do without the biosphere. So as I've said before, green energy is not green. It's an alternative to the biosphere. It's an effort to create a new biosphere, one without photosynthesis, one without plants and animals, and therefore without you and me, if it's taken all the way. I'm nothing against small amounts of green energy, but if you try to live in a way that depends almost entirely on it, then you're subtracting yourself from the picture. Non-plant energy sources always demand their pound of flesh from us. So we always have to make some sacrifice to get energy from any source, whether it's plants, living or dead, or whether it's wind or solar or nuclear or anything else. We have to take risks, we have to use resources, time, working hours, and in the end, if we could calculate the resources required to build more wind or more of any renewable, we'll always decide not to build that much. That's what the previous episodes were talking about. One particular way of pricing things is the money system that we have right now, and according to the money system that we have right now, the way that we have pricing things, they just cost too much and we won't build that much. But that particular pricing scheme doesn't give you a full picture of all the risks and all the effort and everything that goes into using renewables, and all the consequences. If you could keep track of all the consequences, perhaps you would be even less likely to build so many renewables. So this discussion of the last 10 minutes or so about the advantages of the biosphere are just, I hope you can see that it does have advantages, and they're hopelessly superior to what we have on offer, and that's why when push comes to shove, we always find that building renewables takes a lot more effort and risk than we're willing to give. We have a better option, and that better option is living from the world's plants, either the ones that are alive today or the ones that died millions of years ago. Okay, now I want to go on to another point. This is a stepping point, a stepping stone on the way to the final point of this episode, which is how much energy are we likely to get from the biosphere or from renewables. Okay. Specifically, I didn't mean the biosphere, from renewables. So I'm going to arrive at how much energy we're likely to get from renewables at maximum amount of energy. But first I need to make an intermediate point, okay? And that point is, okay, well, suppose you believe me that the biosphere is the best for our needs, it's nearly optimal, okay, compared to anything else, but couldn't it be better? Couldn't the biosphere, as I said, we get, with the help of the biosphere, 1 out of 4,000 calories from the sun. Couldn't we do better? Can we do a factor of 10 or 100 better? And the answer is no. We aren't going to do much better. The no has two reasons. One is the biosphere and one is us. Okay. Let's talk about the biosphere first. It's been around for 2 billion years, and it's anything that could harvest energy and was doing well at it just grew, and grew and multiplied itself, and every living being in the biosphere is eager to maximize its harvest of the sun's energy, to try to get as much energy to grow as well as it can. It's all trying. Everything, every single protozoan, every single plant, every single insect is trying to maximize its species, itself, its harvest. This has been going on for 2 billion years, and I would like to point out at this point, very few people have any success at imagining their own lifetime and really coping or planning for the fact that they're going to be dead in 50 years or 100 years. It's very hard to imagine what it'll be like when you're no longer able to control your bladder, things like that. Let alone anything else that happens, the way that history will turn out. We have a very limited grasp, even over decades of history, hundreds, a century or two. Things beyond our memory are almost mythology. The human race does not have written records of anything more than 5,500 years ago. So 2 billion years is an unimaginable amount of time. It's beyond, it's a number you can write down, but it's not a number you can understand. And the biosphere has been living for those 2 billion years, and it's been covering the entire globe. It still does. And you might think when you're on an airplane looking down on the globe that you're comprehending, or when you're watching a movie of satellite footage, you might think that you're comprehending everything you're looking down on, but you're not. You're not in it, and you have very little idea what you're looking at. The scale, the physical scale, the size of this biosphere dwarfs our comprehension, and the time dwarfs our comprehension, and moreover, take a handful of soil, and you'll, in that handful there'll be millions of beings there that you don't see and you didn't know and you never will know are there. Thousands of species in that handful of soil. They grow everywhere, and different species in different places. And then you think of all the species that lived 1 million or 100 million years ago, the ones that are extinct. Have come and gone. And all of these, an unimaginable length of time, millions of species today that we don't know about. We still have not found nearly all of the species. Far more of them in the past. Over in the world's continents, which is an easy word to say, but it's another thing to know. No person knows. No man knows all the world's land, and no man ever will. And all of these beings have been trying to maximize their harvest. So when we're confronted with something far beyond ourselves in time and space and numbers of species, and not to mention how they work together or compete, but they work together, they make there must be a very good reason for why the biosphere's harvest is the number that it is. They've been trying. The world's species have been trying for 2 billion years, and they've got this far. About 11 times what our harvest is from the biosphere. Would be around 200,000 calories per person per day. So I'm just saying, you have immense amounts of strife and effort from countless beings for billions of years, don't think we're going to improve its harvest that much. Now, as for the human race, for our portion of the harvest, well, I think that also deserves some respect. We started farming about 10,000 years ago, and the first farmers were doing genetic engineering through breeding. They weren't stupid. They were smart. Every species that we farm today, every plant and every animal, is far different than it was when it got started. The grains that we live off today, that most of our calories come from grains, were originally grasses that had maybe 10 kernels, 10 small kernels growing at the end of the grass. We didn't just breed everything like crazy. We also restructured ourselves. We restructured our societies again and again and again. Our families, we invented and invented again, and we re-architected the land. We've also destroyed huge quantities of land as we went. Our individual people's lives depended on harvests. The rise and fall of families depended on their harvest. Empires, this has been true for the last, all through history. An empire thrived if it was able to harvest well, if it got good harvests, and an empire collapsed if it could not. You can imagine that whether your country lives or is destroyed by invaders depends on whether you harvest well, whether you grow your crops well, that you'll throw huge amounts of effort into that, into your farming, in your your flocks. And we have. The large majority of the human race throughout history has been dedicated to the land. 7 days a week, and huge amounts of risk, countless deaths, people working themselves to death, entire lifetimes spent on the land. Most of the world's population over history, probably better than 9/10 of the world's population, has been working the land. And still today, even in this high-tech world, still half of the world's population is on the land or in small towns on the land, organized around getting stuff from the land. Only a half today is in cities. And by now we're using the majority of the world's land. So 10,000 years of history, countless innovations, huge amounts of sacrifice, almost the entire, if you add up all the members of the human race over history, almost all of them spent almost all of their time on the land. And by now we use 1 out of 11 calories that the biosphere harvests. Now, you can imagine that when there are only a few thousand or a million of us, that we used a lot less. We've doubled and doubled and doubled our consumption of the biosphere's harvest again and again and again, until by now we are the dominant species. We are by far the dominant animal species. Take everything else with spines, you compare it to us and our livestock, it's like 100th by body weight. We dominate. And so you might think that over the last century, when we continued to double our consumption from the world's land, we were doubling our consumption of everything else every 22 years or so. Maybe it was 24 years over the last century. You might think that we would have doubled our consumption of the world's harvest, of the biosphere's harvest, every 24 years. So that would have been, over a century, that would have been multiplying our consumption of the world's harvest of its plant calories and meat by a factor of 16. Instead, we only doubled once in the last century. So doubling once over 100 years is pathetic compared to every other resource that we've used. Even lead, which is poisonous, and mercury, we reduced our consumption of mercury for a little while, and then we started increasing it again. Every resource has multiplied by 2 over and over again, except the energy that we get from the world's land. It's only multiplied by 2 in 100 years. And that means we've basically maxed out. We might improve a little more. It's going to take more than 100 years to double again, if we ever do double. Okay, I'll get into in the next episodes the possibilities for doubling our harvest or for improving it at all. It's going to be an awful lot of work. It would involve the whole human race working like crazy on an indefinite basis, continuous basis, forever, to keep our harvest higher than it is now. And even then, even if we do devote ourselves full time to improving our harvest from the world's land, we still might not get even a factor of 2, and we might even lose some. Because as it is today, the harvest that we do obtain from the world's land is done at the price of continual destruction of the world's land and species. And as we are forced to make adjustments to that, and also as we are forced to use less energy as we're farming the land, because energy will be harder to get, we may find that it's harder to get even the harvest that we obtain today. So overall, I'm saying we won't get that much more from the biosphere. The biosphere is already far beyond our comprehension. It's just clear that it's worked like crazy for billions of years to get the harvest that it gets today. We can't expect it to do much better. And the human race has worked like crazy for 10,000 years farming, and devoted its best minds, its best talent, and its brawn for 10,000 years. You can't expect that to get much better. Well, I think with some effort there's a chance we might be able to multiply the biosphere's harvest from 15,000 calories to our fraction of the harvest from 15,000 to 30,000 by doing better things with the land and the things we grow on it. There's a chance, but we might not even get that far. I'll cover this in the next episodes. Okay. And the biosphere is nearly optimal, as I've discussed. It does just about the best for our needs, our specific needs. And the other options that don't involve the biosphere, the renewables and nuclear, are not nearly optimal. They're not as well suited to us as the world's plants and animals are. We aren't as well suited to them as we are to the world's plants and animals. We don't have an electrical hookup in our bodies. So therefore, the renewables and nuclear are more burdensome to us than the biosphere is. So whenever we take a clear look at the burdens that come with harvesting energy from wind or solar or nuclear or any of the others, we'll always find that the burdens are larger, and we'll always find that we're not willing to take from them, to harvest as much from them as we harvest from the biosphere, because they just require more pain and sweat and sacrifice than the biosphere does. So the biosphere today gives us 15,000 calories. It might, with a lot of luck and a huge amount of effort, give us 30,000 calories per person per day. And the renewables and nuclear will always be worse than that. So if the best we could ever get from the biosphere is 30,000, then, and renewables and nuclear will give us a fraction of that, then, well, maybe a fraction of 30,000 might be 10,000 or 15,000 calories per person per day from renewables. I keep saying things like might be. We might reach 30,000. Maybe a fraction would be 10,000 or 15,000. In a way that may sound a little wishy-washy, but this is just rigorous thinking. You have to be clear about the things you don't know. You have to be clear about there being imponderables, but you also have to be clear about the things you do know, that you aren't going to get that much more from the biosphere, and that the renewables will always give you less. Much more would be a factor of 2, no more. Less means substantially less. So at least a factor of 2, a factor of 3 less than the biosphere's maximum harvest. So in a way, it may sound a little vague, but I think it's far more rigorous and far stronger reasoning than the reasoning we went over with the price of wind and solar and nuclear. This is stuff where you can't say, okay, well, maybe I can get it on sale on Black Friday. This is really unforgiving logic. It may feel like there's a little bit of give to it. There is a little bit of give, but behind that is something that just you can't mess with at all. It's an immovable object, the biosphere is, and the fact that it gives us better than the renewables do. At any rate, a fraction of 30,000 calories is 10 or 15,000 or maybe less that we could get from renewables at a reasonable cost, at a cost that we would be willing to spend. And that comes out roughly in line with the estimates that I came up with based on prices in the previous episodes, which were 10 or 15,000 calories per person per day, averaged across the world. So that's 2 lines of argument. The first one relied on today's pricing, and the second one is all about the advantages of the biosphere and how much we could improve the biosphere, how much it's likely to get better even with effort. Both come up with a number between 10 or 15 and 15,000 calories per person per day from renewables and nuclear. And sometime a little later, maybe 10 or 20 episodes from now, we'll come up with an even stronger line of reasoning that will say that renewables will never give us more than a fraction of the energy that we get from the biosphere. It will never be more than a supplement. So, in the coming episodes, I've discussed coal, oil, and gas. We will find that sooner or later, and not too long from now, that there will be less of it on hand at the prices that we're willing to pay for. So we'll be doing with less of coal, oil, and gas. And we won't be able to make up the difference from renewables and nuclear because they just are more burdensome. We've now argued twice, 2 different ways, that they're more burdensome, more costly, and we just won't be willing to spend enough to build a lot of wind, solar, and nuclear, or any other renewable. So the only remaining way to get energy, aside from coal, oil, and gas, and the renewables, nuclear, is to grow today's plants and forests, crops and forests, to get more energy from them. And I've told you already what the answer is. We would be doing very well if, with a huge, prodigious effort, 100 years from now or 200 years from now, we could get double the harvest from the world's plants that we do now. And that's about as good as we can get, we could imagine getting. In the next episodes, this next episode will be a summary of the last 20 episodes, trying to sum it up quickly, maybe in a half hour if I can manage. I don't know. Keeping things short is not my strong point, but I'll try. And then after that, I'll be going into the technicalities and details of the biosphere, enough to give us an idea of what we could do to improve our harvest, and what's not likely to work, and what might work, and how we could do it. But that's the only remaining option for trying to keep our energy harvest where it is now, 46,000 calories per person per day. That would involve tripling our harvest, multiplying our harvest from the biosphere by 4. Which, as I've told you, it's not going to work out that way. Yeah. So I hope the main point here is we're about to put the last nail in the coffin. Okay, we nailed down coal, oil, and gas. Then we nailed down renewables twice now. And the third nail in the coffin will be nailing down the maximum harvest and what we're likely to get from the biosphere and what we would need to do to get that harvest. Then we'll do a third nailing on the coffin, a third attempt at renewables, and then we'll be done. And we'll know at that point that we'll never be able to sustain 46,000 calories per person per day. Okay, well, keep coming back, and yeah, keep coming back.